Welcome to the first Honors Chem lecture, virtual, of course, because we're not in school right now. And this is the safer way to do it. So we're going to jump in. Our first unit is on matter, measurement, the mole, and energy. It's a lot of things. Traditionally, this unit takes like a month or more. I don't know if it's going to be that long, so I just don't know if we can do all the things that go along with it, specifically the labs and some of the activities. So this unit might be a little bit shorter. Usually I break it in half. I don't know if I'll do that this time, but you probably don't care. So let's jump in and talk about our first topic for today, which would be matter. Chemistry, you might have some definition in your head of what that means, what it is. According to the book, it's concerned with properties of chemicals and the changes that chemicals undergo. By the way, feel free to pause this. I get to go a little bit faster because you're not looking at me with your weird faces, so pause it if you want to write things down. I'll also post the notes on Schoology. A chemical is a substance that has any definite composition. So things that you know, definite composition means that it's like the same universally all the time. So for example, water, H2O, has the same composition, looks the same, acts the same, is the same every single time. Sugar, C12H22O12, has the same composition every single time. So that's what we call a chemical. Those chemicals can undergo chemical changes, which we call chemical reactions. So you see those all over the place, all around you, and you see them inside you. For example, if you ate your breakfast this morning and you're digesting your food right now, or if you brushed your teeth. These are chemical changes that happen in your body that happen every day that you don't think about. Right now, leaves are changing. So that's a chemical change under the leaves on the trees undergoing a chemical change right now as we speak. Again, all these things happen around you, so it's easy to see them. That's why chemistry is a very easy subject to understand. It's an easy subject to teach because I get to use all of these real-world examples for you. I just said that. Chemical changes take place all around us and inside of us. So, matter. Any chemical reaction in all of chemistry involves what we call matter. Matter is basically everything. Okay, it's defined as anything that takes up space and has mass, even if you don't think that it does take up space or has a very, very small amount of mass, it's still considered matter. So for example, gases, they're very, very small. The particles are very spread out. And even though they don't take up a lot of space and they don't take up a lot of mass, they still take up some, and so that's considered matter. Protons, neutrons, electrons, the parts that make up atoms, those still have space and they still have some mass. It's very, very small, as you can imagine, and we still consider that matter. So basically, matter is anything. Okay. Oh, hey, I'm one ahead again. How do I do it? I'm just that good. Matter has 3 states. Maybe you've heard of them. Actually, technically has 4. The 4th state is called plasma, but maybe you've heard of solid, liquid, and gases. Plasma is actually the most common state of matter in the universe because stars are made of plasmas. Plasmas are super hot, ionized gases, so they have a charge and they are gases and they're very, very hot. Lightning would be an example of a plasma, or fire would be a plasma on Earth. But universe speaking, which is very big, obviously, since stars are made of plasmas and there are billions and trillions and billions and trillions of stars, then that's the most common state. But here on Earth, we focus on the 3 states, and in this class, you probably already know what they are. We've got solids, which have a fixed volume and a fixed shape, and the particles are packed closely together, so that's the way it stays, and that's the way it looks. If you take your pencil and put it on your desk, it doesn't like spread out to fill the desk or like spill over the side of a desk because it's solid, and the particles are very close together, and they can't roam around one another. We also have liquids. Liquids have a fixed volume, but not a fixed shape. Particles are a little bit further apart. If you have, let's say, a gallon of water in a gallon jug and you pour that gallon of water onto the floor, it's still a gallon of water, but the shape has changed. And the reason the shape has changed is because the particles are a little bit further apart, so they have some room to roam around and roll past one another. And finally, you've got gases. Gases don't have a fixed volume or a fixed shape. There's lots of space in between them, and they can be compressed. Like if you think about all the gas in your room right now, you could take it, smush it together, and put it into, like, let's say, like a helium tank, that kind of thing. And then if you let the helium tank go, the gas would spill out of there and fill up your room. So they don't have a fixed volume or fixed shape. They have lots of space between their particles. If you have 1 million molecules of gas, let's say, in your room, You can change how much space they take up. You can change what shape they are, but you will not be able to change how many particles there are. So that's what stays constant. So 3 states of matter, and then of course the fourth one, plasma, is not really covered in this class, but very, very common if you're talking about like the universe. Oh, these would be cute pictures if they worked, but they don't. We've got solids, they're very close together. You can see them right there. We have liquids a little bit further apart. Notice that solids are very ordered. Liquids are a little further apart. Gases are very far apart, and they're not ordered. Solids would be like ice cubes. Liquid would be like liquid water that you drink. And then gases, if you heat that water, these bubbles that form in the water and that form up, and then the gas that forms up here, we call that steam. That's just water that's a gas. This is the kind of picture you might see on a test or a quiz sometimes. So either take a mental picture or take a real picture. Matter can undergo 2 kinds of changes, and you're probably familiar with both of them, but we give them some names and some terms here in honors chemistry. The first one is called a physical change. You can change the matter, and that would not affect the identity of the substance. So, for example, if you take a bottle and you smash it over your friend's head, it was a glass bottle before. It's still glass, but now it looks differently. And so that would be a physical change. If you take a stick and break it, if you cut your hair, these are examples of physical changes where the thing studied before and the thing after is the same. You just rearrange the way that it looks. It's a physical change, okay? Even some of the trickier ones like water boiling, the formula for water is H2O. It has 2 hydrogens, 1 oxygen. If you boil it, the formula for steam, guess what? It's still H2O, just now that the water is no longer a liquid, but it's a gas. That's a physical change. We didn't change the identity of the substance. We just changed the way it looks. Physical change. Now, the opposite side, oh, of course, there's examples. Ice melting, water boiling. I just said some of them. The other side of that are called chemical changes. Chemical changes are you basically change the identity of the substance and you make a new substance. You can identify a new substance because it has different properties from the original substance, and usually in a chemical change, the process is irreversible, so you can't go back. So for example, if you fry an egg, cracking an egg, that is a physical change, right? Just like taking the inside of the egg and putting the outside, physical change. But if you fry it, cooking, you're not going to get the original egg back. So that's a good example of a chemical change. And any cooking, baking, toasting, anything with food like that, that's always going to be a chemical change. You can't get the original stuff back. If you, take a piece of ham out and put it on your countertop, it's not going to turn back into a pig. That was a weird example, but you get the idea. Baking a cake, you take all these ingredients, you put them together, you get the thing, put it in the oven, and you can't like set them back out on the counter and like watch the eggs come back. It's impossible. That's a chemical change. I already said this, but changes of state, so anytime you go between solid, liquid, and gas, those are always physical. The changes of state, we'll come back to what those names are, but you probably have heard of them like melting, freezing, evaporating. All of those are physical changes. So think about solid ice. Its formula is H2O. You melt it. Now you can drink it, right? It's liquid water. Its formula is still H2O. But melting it, that's a physical change. You didn't change what it was. And again, I already mentioned the boiling. You take that liquid and you boil it. Now its formula is still H2O, but now it's a gas, and so that is a physical change as well. So changes of state, going between solid, liquid, and gas, always physical. The words that would key you off there: melting, freezing, boiling, evaporating, those kinds of words. Condensation. Oh, cool. Here's an example: water boiling. Always one step ahead. I'm very good at this. Popsicle melting. It's still delicious, but now you have to lick it off the ground. I'm just kidding. Don't do that. Not recommended. We would probably do this in class if you had if we had time and I was looking at your weird faces, but I'm not. So here are some following. You can classify them on your own. Shattering glass bottles, physical. A tire deflating is physical. Rotting wood is chemical. You can't get the original wood back. Toasting bread, also chemical. You can't get the original bread back. Shredding paper is physical. Leaves changing color. They change color. They die. They don't come back. You get new ones that grow. That's a chemical change. Oh my goodness, look at these transitions. Absolutely ridiculous. Who would put these in? That would be a really funny joke if we were seeing each other. Chemical changes taking place usually one of 4 ways in this class. And so these would be ones that you'd want to memorize whenever we have a quiz or a test. So 4 ways a chemical change is taking place. The first one is that your bubbles are forming, and I don't mean like you make bubbles like by boiling something, by heating it up. That's a physical change. But I'm talking about taking 2 things, mixing them together, and now all of a sudden bubbles form. Or you take a rock or metal, and you plunk it into something. Like let's say you plunk it into some liquid, and it forms some bubbles. That's a chemical change. You made a new gas from two things that were not. Energy transfer, if something gets hot or cold, it's a good indication that a chemical change is taking place. For example, put your hand over a fire. It feels very warm. That's because a chemical change that is happening on the log that releases a lot of energy. So a good example of chemical change. Again, I'm not talking about stepping outside and feeling cold. I'm talking about like mixing two things together that get hot or cold. That is an example of an energy transfer, which is an example of chemical change. Color change, leaves changing color in the fall, for example. Metal rusting, changes from shiny metal to gross rust color. That is a good example of a chemical change. And then finally, formation of a solid. You take two liquids together and you mix them together, and all of a sudden like a little chunky solid forms at the bottom. Just kidding, it doesn't need to be chunky. It can be any kind of solid. Let's not solid shame. But so if it forms a solid, then it's going to be a chemical change, and we call it a solid precipitate. That's the word that we use to say that the solid formed. You can classify matter all sorts of ways. There's kind of this convoluted way, but we'll go through all these words and you'll see them. Matter, and then at the end of this last part, there's like a little, what's that called? Like a flow chart that shows you like the words we'll learn. We'll learn about 8 different terms here. So matter is broken down into 2 categories. You got pure substances. Anything with a pure substance, anything that is a pure substance has a chemical formula and properties that are known. So for example, sugar. Sugar has a chemical formula. I already mentioned it's got 12 carbons. It's got 22 hydrogens and 12 oxygens. We call that sucrose, I think. I don't know. I'm not a biologist, but you get the idea. It's got a chemical formula. All sugar is exactly the same. So that is what we call a pure substance. Water, pure substance, okay? Chemical formula, you already know its properties. Oh my gosh, I said those two. And then you've got gold. Anything on the periodic table, by definition, excuse me, is a pure substance. And so any of the 115 elements, a pure substance for sure. Now, the other kind of thing that's not a pure substance that we call mixtures. Mixtures are combinations of 2 or more pure substances, and they're physically combined. So, for example, syrup. I say syrup. Is that okay? You might say syrup. It doesn't really matter. But there's no chemical formula for syrup. So that is a mixture. It's a mixture of, I don't know, maple and water and whatever else is in there. Or gasoline. There's no formula for gasoline. It's a mixture of a bunch of different things. Gatorade. Is there a formula for Gatorade? No, there's not. So these are mixtures. You're taking some basic pure substance ingredients and you're physically joining them together to get delicious Gatorade or whatever else. So air is actually a mixture of nitrogen, oxygen, and some other garbage we breathe. Sand, that's not. It's a mixture of all sorts of trash. Salad, that's a mixture too. It's delicious lettuce and gross tomatoes. Underneath those, you can break each of them down into a few categories. So pure substances can break down into elements. So anything on the periodic table obviously is an element. You can't break it down more. That's as basic as it gets. Elements have their own pieces. We'll get to that next unit, but the basic building blocks of all pure substances are made from elements. And then, I just said that. So you could take like a, let's say, I don't know, chunk of copper, a penny, and start cutting it up and cut it up some really, really small, and you get it down to the size of 1 atom. 1 atom of copper would have the same properties as a penny made fully of copper. So it would, when I say smallest representative unit, I mean that it has the same properties. If you cut that atom up, then it no longer acts like copper. And then you've got compounds, which are more than one type of element, and they're chemically joined together. And if you take a compound and break it down into its smallest part, we call that a molecule. So, for example, water, a big cup of water, all the water molecules in there are H2O, and you start cutting them up and you isolate one water molecule. That one water molecule, that one H2O has the same properties as the big cup of water. Boiling point, melting points, density, all the same. But if you take one of those O's off, one of those oxygens off, then you have a different compound entirely. So molecules are said to represent the smallest part of the compound. Molecules are often made up of at least 2 types of atoms, but there are molecules that are made up of 1 atom. So for example, oxygen that we breathe, think in your head, I'm breathing oxygen. What is the formula for oxygen? You're probably thinking O2. O2 is 2 oxygen molecules or atoms joined together, and that's what we call oxygen that we breathe. All right, so then on the other side, you've got mixtures. You can break those down into 2 categories as well. You've got homogeneous mixtures. Those are mixtures that are uniform throughout. So those ones are the same I think of like food, although you shouldn't eat things in this class, but I mean, things that you get the same experience every time. So Gatorade, every drop is the exact same. Take some Kool-Aid, mix it up well so that there's no gross Kool-Aid at the bottom. That is a uniform mixture. It tastes the same first drop to last drop. Even solids are called, they're mixtures too. So for example, steel, there's no chemical formula for steel. It's made up of iron and nickel and some other stuff as well. And when you melt it down and mix it together, then that steel bar is exactly the same, whether you're at one side or the other. That's called a homogeneous mixture. And then heterogeneous mixtures are ones that are not uniform throughout. So like sand, if you're at, what's your beach called over here? Lake, I forget. But let's say you're at my beach, Lake Harriet. If you grab a handful of sand in one spot and take 3 steps and then grab another handful of sand, they're not going to be the same. That's a heterogeneous mixture. A salad, sometimes you jam your fork in there and it's like all croutons and bacon and cheddar cheese. And sometimes you get like a gross radish. Okay, so every time is different. That's what we call a heterogeneous mixture. Oh my gosh, here is the picture as promised, showing you how everything fits together. We've got matter. Hope you can see my cursor. That's everything. And then you've got the 2 kinds of matter. You've got pure substances and you've got mixtures. And then underneath pure substances, you have elements, and compounds is how all the words fit together. Underneath mixtures, you've got heterogeneous, not uniform, and homogeneous, uniform. Hey, there you go. That's the first lecture in honors chemistry. Hopefully most of that's a review for you. Anyway, this has been fun. We'll see you soon.